The other day, we were trying to test the continuity of the primary winding of this power transformer. By the way, it's a standard utility power transformer that you'll see on a pole mounted outside your home in the United States, typically. We wanted to test this power transformer and make sure we had continuity through the primary winding. So we decided to take a pretty common Fluke 87 multimeter and do a resistance check for continuity. And here's what we found. When we took this meter and set up to measure resistance, we got this weird flashing display. You can see that it just can't seem to lock into a reading. And that was a mystery. We wanted to know why. So we did some investigation, and I'm here to talk about what we found. First thing we found is if we take the range button and we force this to go into a manual range instead of automatically ranging, it works just fine. It immediately tells us, yes, we have continuity. There's a very low resistance in this primary winding, and everything's okay. Why did it work well here, but it did not work well when it was in the auto range mode? In the auto range, it just flashes like that. Well, we have to understand a bit about how these devices actually auto range. When you go into different ranges of resistance measurement, what you're telling the meter to do is to force different amounts of current through the test resistance. So I'm going to take this analog meter over here and I'm going to configure it for reading milliamps. It's on the 1 milliamp scale. I'm going to take its red and black leads and connect directly to the red and black leads of the Fluke. So right here, what we can see in this particular range, we're going up to, on the 1 milliamp scale, that's about 3 milliamps of current DC. But then if I switch the range here, it's going to use different amounts of current. Can't even see the needle move on that one. Here we go. There's a different amount of current right there. Different amount of current right there. Less current, etc., etc. The higher you go in the measurement range for resistance on this meter, the less current it is forcing through the test resistance. So in the auto range mode, what it's doing is it's starting with one level of current, and if that proves to be too much or too little, it shifts to another range of current to get the appropriate measurement. So this device is acting as a current source with a bunch of different steps, depending on what range it shifts to. Now that's a problem when you connect it to a large amount of inductance, which is what we have in the primary winding of this transformer. This is rated for 7,200 volts, pole to pole here, and that to have a low amount of magnetization current when this is energized by our power line, that means the primary winding of this transformer has to have a lot of inductance. I don't know how many henries it is, I haven't tried measuring it, but it's a lot of inductance. So inductance, of course, stores energy in the form of a magnetic field that is proportional to the square of the current that you put through it. So when I connect my ohm meter here to this large inductance, what it is trying to do is push a current through that inductance, which of course creates a magnetic field and stores some energy. In the auto range mode, it starts with one level of current, and if it deems that that's dropping too much voltage, i.e. there's too much resistance there, it will shift to another level of current. And when it shifts to another level of current, that's when the trouble begins, because now it's trying to change the amount of magnetic field in that core of the inductor, and when that happens, the inductor reacts by producing voltage drops that will change polarity. So let me demonstrate this. I'm going to set the analog meter to a low DC voltage scale, in this case the 2.5 volt scale. I will set the analog meter to read the voltage across these two terminals of the large transformer. At the same time, I'm going to use the Fluke meter to try to measure resistance between those same two terminals. Let's see if I can hold 4 leads by myself. And look at that. Take a look at the analog needle. It is twitching back and forth. So that is showing the Fluke meter trying to push current through the inductance, shifting ranges. The inductor reacts by producing a different voltage drop. The Fluke meter thinks, oh, I have to go back to the range I was at before, and it goes back and forth, back and forth, back and forth. This is a common problem when you have any electronic device trying to act as a current source powering up a large inductor. Remember, inductors store energy magnetically, proportional to the square of current, and so any attempt to change the current will result in energy being absorbed or released, and that in turn causes the meter to kind of freak out when it's in the auto range mode. Again, shifting to manual range. If I shift to a manual range here and I repeat my experiment, maybe I can help myself out here by sticking this lead there of the analog meter. Now, if I take the analog meter, connect it there and there, I take the digital meter, and I'm not making good contact. Of course, this only happens when I'm shooting a video. There we go. Now, what happens here, you'll notice every time I connect the fluke meter and release it, notice what the analog voltmeter does. When I connect the fluke meter and trying to energize the inductor, I get a voltage of one polarity as I'm building up energy in the core. Then as I disconnect the ohm meter, that magnetic field collapses, producing a voltage of the other polarity. As the meter is trying to change its range of current, a similar thing happens. You get this essentially oscillating DC voltage polarity across the inductor. One way is it's charging, one way is it's discharging, and that reversal of polarity confuses the fluke meter and causes it to go into a different resistance measurement range. So, in the auto range mode, it looks like it's freaking out, but only with a very large inductance.
Cool.